Today we'll see the topic is support vector machine, the SVM in machine learning. First see the content. The first one, introduction of SVM, then examples of SVM. Next one is the classification of SVM, hyperplan, support vectors in the SVM. First we will discuss the definition for SVM. So the SVM is the support vector machines. It is one of the most popular supervised learning algorithms, which is used for the classification and regression problems. However, mainly it is used for classification problems in machine learnings. Already you know the types of supervised learning algorithm. It is two categories. One is the classification, another one is the regressions. So SVM is applicable for classification and regressions. Next, the aim of the SVM algorithm is to create the best line or best decision boundary that can segregate in n-dimensional space into classes, so that we can easily put the new data point in the correct category in the future. This best decision boundary is called the hyperplan. Here, the SVM select the extreme points or extreme vectors that help in creating the hyperplan. These extreme cases are called as support vectors, and then its algorithm is termed as support vector machines. So here consider the below diagram in which there are two different categories that are classified using a decision boundary or hyperplan. Here see the two categories. One is the X1, another one is the X2. Here using the two data set. One is indicated by the green color, another one is indicated by blue colors. Here see that it's the maximum margin. The center straight line is the maximum margin hyperplan. The nearest hyperplan, the data set is the support vectors. So these 2 points, these two data points are called support vectors. So it is a negative hyperplan. This is the positive hyperplan. Then one more examples. Here SVM can be understood with the examples that we have used in the KNN classifier. Suppose we see a strange that also has some features of dogs. So if we want a model that can accurately identify whether it is a cat or dog, so such model can be created by using the SVM algorithms. We will first train our model through the training dataset with lot of images of cats and dogs, so that it can learn about different features of cats and dogs, and then we test it with this strange creature. So a support vector creates a decision boundary between these two data sets, that is the cat images and dog image, and select extreme cases, that is the support vectors. It will see the extreme case of cat and dog. On the basis of the support vectors, it will classify it as a cat. Consider the one diagram for the SVM. Here see the two category of data set. One is the cat image, another is the dog image. It is the trained labeled data set. It is goes to the model training. Here only we using the SVM algorithms. Then with the predictions. In final, its output, it is a cat image or it is a dog image. That is, SVM algorithm can be used for face deductions, image classification, text categorization, and extra. Some properties of SVM. Here, it is flexibility in selecting a similarity functions. It is the one main properties of SVM. Fairness of solution when dealing with the large data sets. Only support vectors are used to specify the separating hyperplan. Then ability to handle large feature space. Here we are using the large data set, which also feature space also large. Then complexity does not depend on the dimensionality of the feature space. Overfitting can be controlled by soft margin approach. In machine learning, the overfitting is one of the issues. In SVM, it is overcome by the soft margin method. Next, ICE max property. It is simple convex optimization problem which is guaranteed to converge to a single global solution future selection. Next one, types of SVM. Here mentioned two types. One is the linear SVM, another one is the non-linear SVM. So first we see the linear SVM. It is used for linearly separable data, which means if a data set can be classified into two classes by using a single straight line, then such data is termed as linearly separable data and classifier. So it is called a linear SVM classifier. So in linear SVM, into two classes using a single straight line. That's the main thing in linear SVM. So non-linear SVM, this type of SVM is used for non-linearly separable data, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear data and classifier. It is called a non-linear SVM. Next one, example for SVM. The working of the linear SVM algorithm can be understood by using an example. Suppose we have two data sets that has two categories. One is the green and another is the blue. And the data set has two features that is represented by x1 and x2. So we want a classifier that can classify the pair of coordinates like pair of x1, x2, the coordinate points in either green or blue. It is the example diagram for the pair coordinates in linear SVM. Next is the hyperplan and support vectors in the SVM algorithm. Here the hyperplan, there can be multiple lines or decision boundaries to segregate the classes in n-dimensional space, but we need to find out the best decision boundary that helps to classify the data points. The best boundary is known as a hyperplan of SVM. So, finally, the best boundary is called a hyperplan of SVM. Here, the dimensions of the hyperplan depend on the features present in the dataset. So, hyperplan is dependent on the features in current dataset, which means if there are two features, then hyperplan will be a straight line. And if there are three features, then hyperplan will be a two-dimensional plan. We always create a hyperplan that has a maximum margin, which means the maximum distance between the data points. Next, as it is two-dimensional space, so by just using a straight line, we can easily separate these two categories of dataset. But there can be multiple lines that can separate these classes. One examples for multi-lines used in the SVM. So we have two datasets, but we are using the two straight lines. Hence, the SVM algorithms help to find the best line or decision boundary. This best boundary or region are called the hyperplan. It is already discussed of the definition of hyperplan. The goal of SVM is to maximize this margin. The hyperplan with the maximum margin is called the optimal hyperplan. So the hyperplan with the maximum margin, it is the optimal hyperplan. SVM algorithms finds the closest point of these lines from both classes. These points are called the support vectors. The support vector means the closest point in the margin. The distance between the vector and the hyperplan is called the margin. So margin is the distance from vector support vectors to hyperplan. Let us say there are m dimensions. Thus the equation of the hyperplan in the m dimension can be given as y equal to w0 plus w1 x1 plus w2 x2 like that. Next w0 plus summation I equal to 1 to m wi and xi. Next is converted to w0 plus w transpose into x. Next w0 is converted to bias b plus wt into x. Here wi is the vectors like w0 to wm. P is the bias terms, x is the our variables. Next, some advantages and drawbacks of SVM algorithms. Here, it is really effective in higher dimensions. Effective when the number of features are more than training examples. Best algorithm when classes are separable. This mostly is the linear SVM. The hyperplan is affected by only the support vector, the outliers have less impact. SVM is suited for the extreme case binary classifications. Is the advantages of support vector machine algorithms. Next, some drawbacks. Here, for large data set, it requires a large amount of time to process. So it is already does not perform well in case of overlapped classes. Selecting the appropriate kernel function can be tricky. The last one is selecting appropriately hyperparameters of the SVM that will allow for sufficient generalization performance. Next, few applications using SVM. SVM has been used successfully in many real-world problems such as image classifications and bioinformatics field like protein classification, cancer classification, the medical applications, then handwritten character recognition. This is the some applications of SVM algorithms. Next one, quiz about the support vector machines. Here see the question. Suppose you are using a linear SVM classifier with two class classification problem. Now you have been given the following data in which some points are circled red that are representing support vectors. If you remove the following any one red points from the data set, does the decision boundary will change or not? So here you have one data set. It is represent the plus and negative minus signs. So the points removed from the data set mean the decision boundary will change or does not change. That's the question. Here answer is the true. Okay. Thank you.